Good morning. Welcome to RT208 Imaging Equipment and Maintenance, Module 3, the X-ray imaging system. Particularly, we will be discussing the X-ray machine, the type of X-ray machines, and the filament and tube currents. Objectives. At the completion of this presentation, the student should be able to do the following. 1. Discuss the main component of the X-ray imaging system. 2. Identify the different types of X-ray machine. 3. Define and differentiate filament and tube current. There are different types of X-ray machines. As you can see in the slide, the X-ray imaging system is designed for radiography, tomography, and fluoroscopy. So its primary function is to provide a controlled flow of electrons intense enough to produce an X-ray beam appropriate for diagnostic imaging. The three main components of the X-ray imaging system are the following. First, we have the X-ray tube. Second, the operating console or the control panel. And lastly, the high voltage generator. The X-ray tube. It is a component of the X-ray imaging system, rarely seen by the radiologic technologies. It is contained in a protective housing, therefore it is inaccessible. Okay? We only know where the location of the X-ray tube, but it is not seen by our naked eyes because it is covered by a protective housing and a glass envelope. The operating or control console. It is the control unit. Provides control of the line compensation, kilovoltage peak, milliampere, and exposure time. It is also based on computer technology. Controls and meters are digital and techniques are selected with a touch screen. Numeric technique selection is often replaced by icons indicating the body part size and shape. Last is the high voltage generator. So basically, it is responsible for increasing the output voltage from the autotransformer to the kVp necessary for X-ray production. So it transforms voltage into kilovoltage. The following are the types of X-ray machines. The first type is the fixed type X-ray machines. So basically from the term itself, fixed, it is stationary, meaning it is installed in a particular place and cannot be moved. So most of our X-ray machines in the clinics, in the hospitals, as well as fluoroscopic machines are fixed. The next type of X-ray machines are the mobile X-ray machines. Yes, it included the portable X-ray machines, okay, the transportable X-ray machines. Basically, they are all the same. They are mobile X-ray machines. So they are designed to be taken near the patient or in the bedside of the patient. Patients who are unable to travel to the radiology department. Example, if the patient is critically in the ER or in the intensive care units, as well as in the operating room before or even after the operation. So these are the examples of the X-ray mobile unit. The next type of X-ray machines are called dedicated X-ray machines. Okay, as you can see in the examples, uh, there are dental X-ray machine. Okay, you can see also a mammographic X-ray machine, as well as bone densitometry X-ray machines. So these X-ray machines are designed for a specific purpose or examination, like the panoramic dental machine or dental X-ray machine. They are dedicated to the panoramic view of the teeth. Okay, and the mammography machine dedicated for the uh, radiographic examination of the breast, and of course the bone densitometry dedicated for the uh, density of the bone. So let's have a recap. So what are the three um, types of X-ray machines? Okay, we have the fixed fixed type X-ray machines, the mobile X-ray machines, and the dedicated X-ray machines. Okay, so now we move on to the filament and tube current. The filament current is the current that flows through the filament. So it is the result from applying a low voltage across the filament. So ito daw ay resulta ng pagdaloy ng mababang voltahe sa pathway ng filament. Okay, when the X-ray machine is turned on, a low current flows through the filament to warm it and prepare it for thermionic emission. So kapag binuhay daw natin ang X-ray machine, may dadaloy ng mababang voltahe sa ating filament upang ito ay mag-warm up para din sa preparation nito sa tinatawag nating thermionic emission. Remember that thermionic emission occurs when the filament is heated up to more than 2000 degrees Celsius. And thermionic emission is necessary for X-ray production. In continuation, when the filament is not hot enough for thermionic emission, it means that the machine is on standby mode. So in order for there to be an exposure, we must increase the current. Once the current is high enough for thermionic emission, of course electrons can be emitted from the filament. And when the filament current is high enough for thermionic emission, a small increase in filament current results in a large increase in X-ray tube current. So we must remember that the X-ray tube current is adjusted by controlling the filament current. A small increase, again a small increase in the filament current can result in a large increase in the X-ray tube current. Now, what is the relationship between the filament current and the tube current? Gaya ng sinabi natin kanina, ang X-ray tube current ay nababago by controlling the filament current. And a small rise in the filament current or a small change in the filament current will result in a large rise in the tube current. And the relationship between the tube and the filament current is dependent upon the tube voltage. Now, space charge. Okay. So, bakit may space charge? Okay. So, balikan muna natin ano ba yung space charge. So, ang space charge ay isang cloud of electrons that can be found in the cathode side of the X-ray tube. So these electron clouds are gathering in the cathode side and are not propelling towards the anode side, thus bringing forth the effect we call the space charge effect. Dahil sa space charge effect, so din na-develop yung tinatawag nating focusing cap. So ano bang kinalaman nito sa tube current at filament current? So later let us see. Okay, saturation current. So this is the highest tube current for a given filament current, and this is called the saturation current. So ito yung pinakamataas na tube current na pwedeng maibigay ng filament current. So remember that the filament current controls the tube current. After the saturation of the tube current, it is now independent of the kilovoltage. And above 1000 mA or 1000 milliampere is what we call the space charge limited exposure. And therefore, kung siya ay space charge limited exposure, it can be a major problem because the electrons will not be able to move from the cathode side towards the anode side. So, yun yung space charge effect. Okay. Kaya siya ay ang saturation current kaya nagiging independent ang tube current sa KB dahil sa kapag in-increase pa natin ang kBp or ang kilovoltage at naabot niya na yung saturation current, yung tube current ay hindi na mababago. Okay? So that is what we mean by independent of the KB because all the available electrons have been used. Okay, so ito yung mahalaga natin tandaan. Okay? So these are my references. Thank you very much for listening to my lecture. Okay. Part 2 will follow and please wait for it for the uploading in the YouTube channel. Thank you very much. Good day.